And thanks for joining me again as we talk about double replacement reactions and solubility rules today. So goals for you are to complete double replacement reactions and then determine whether or not a precipitate will form based on those solubility rules. Okay, so double replacement, we have two compounds reacting. These are typically aqueous solutions. So they're all ions that can mix, and so you get your metals and your two cations switch places. So M and A are just going to swap. So M is with X now, it's going to be with Z later. A is with Z, it's going to be with X later. For example, we get barium nitrate and sodium sulfate to react. The barium and sodiums are going to switch locations, or the nitrates and sulfates are going to switch locations. You have to switch the same, either cations or anions. You cannot put two cations together, you cannot put two anions together because opposites repel each other, like charges repel each other. The positives are going to repel, the negatives are going to repel. So make sure you're switching the right ones. Okay. When we have solutions of these combined, ions can form new compounds that we can have what's called a precipitate form. So if we mix two aqueous solutions, two clear or dissolved solutions, and we get a solid to come out, that is called a precipitate. And there's a way you can tell what your precipitate is. We're going to talk about that right now. So solubility rules. Solubility means ability to dissolve in water. Ability to dissolve in water. Okay, so there's a lot of different rules that you can have. So the basic one that I use is a mnemonic called NAG-SAG. So these substances are always soluble, and N stands for here nitrates. So anything bonded to nitrate is soluble. A is acetate, also always soluble. G here is group 1 metals. So your alkali metals are here. S stands for sulfates. A stands for ammonium. And this G stands for group 17 metals, or your halogens. Okay, so these guys are almost always soluble. There is a little exception, a couple exceptions. One of them I'm going to call PMS. PMS stands for P is lead, M is mercury, and S is silver. Okay, these are your heavy metals. When your heavy metals are bonded to either the sulfates or group 17, they are insoluble. They form a precipitate. Your other exception is Castro-Bear. This S should be capitalized. So Castro-Bear is calcium, strontium, and barium. Okay. These three, when they are bonded to your sulfates, they also become insoluble. And so we can find precipitates based on that. Okay, so on the next slide, we have silver nitrate and sodium chloride reacting. And so in this case, silver and sodium are going to switch locations. But with this, when silver and nitrate are both aqueous, sodium and chlorine are both aqueous. This is your group 1, this is your group 17, this is a nitrate, always soluble. And when they switch, you're going to get silver bound to chlorine, AgCl, and sodium bound to nitrate. So this one is still group 1 and nitrates are always soluble. This one is a group 17, but it's bound to the S in PMS silver, which means that it's going to be a solid. So this is going to form a precipitate. So we have AgNO3 aqueous plus NaCl aqueous produces AgCl, which is a solid, and NaNO3, which is aqueous. Okay, so this solid means that this is going to be your precipitate. Comes out, you should see this. AQ here means that this is going to continue to be dissolved in solution. We'll talk more about this when we talk about net ionic equations in the next video. But for right now, this is what we need to be able to do. So I would like you to be able to include your states of matter here. That double replacement reactions are always aqueous on the reactant side. Your goal is to find out, is there a solid on the product side, yes or no? If there's not, you don't have a precipitate, nothing to worry about. If there is, that's when we get that precipitate. We need to figure out which one it is. Okay? Thank you very much for joining me today. And here's another example. Okay, so we have barium nitrate and sodium sulfate. There's your last one. I'll have you work through this. And I kind of gave you the answers here, but work through this, and I want you to see the the changing of ions and forming that insoluble compound. We'll do more practice with this when we reconvene, but until then, have a great day, and I will catch you next time.